Today we are going to go for multiplexer and demultiplexer. Okay. All right. So let the others come. Meantime, I'll just show you. So our second experiment is implementation of multiplexer and demultiplexer. Okay. You all want me to wait for some time till they come, or should I continue?
Wait, sir, wait.
Wait, sir.
Okay. Okay, guys. I think I will have to continue now. Just tell the others to join in. Okay. All right. So our experiment is as of now implementation of multiplexer and demultiplexer. You all can see my screen, all of you all.
Yes, sir.
Cool. So as I told you, what you got to do is type implementation of multiplexer and demultiplexer VLABs and just click on Google search and you will get it here straight away. Okay. So here is the experiment what we have to deal with, implementation of multiplexer and demultiplexer. So it's the same thing which is here. Okay. So this is the aim, to analyze the truth table and working of a multiplexer, okay, and a demultiplexer. Now a multiplexer, okay, you can even get an IC form also. Okay. Wait, I'll just turn the video on. Okay, you all can see me, guys.
Yes, sir.
So the multiplexer, what you even get the IC type form, wherein on the left hand side also you have pins and on the right hand side also you have pins. So they are totally compact and they are available in IC form. But if you are designing the multiplexer, if you are making the multiplexer, then we have to basically use these 3 input NAND, 1 input NOT logic gates. You can even make the multiplexer using these logic gates as well. So you can even have that IC, or you can even have this. IC is the direct, okay, wherein it will enhance the enhance the output signals for you and give you. So that is your multiplexer. Now, okay, let's go to the theory. I'll just turn off the video for clarity. Okay. So your aim is to basically analyze the truth table and working. So now let's see the theory. What does a multiplexer basically do? Okay. So you have a multiplexer here and you have a demultiplexer. So let's go down and see what the multiplexer does. Okay. Now this is the block diagram of a multiplexer. Now say you have a controller. You all can hear me, right? I'm audible now.
Yes, sir.
Okay, cool. So I'll just tell you what is basically a multiplexer. Say you have a controller, okay? Say it is a Uno board or a ESP32 or a Adreno Mega, whatever. But say you only have 2 pins free, okay? Say you only have 2 pins free. And these pins have to be given to some LED to switch on the LED, okay? Or to switch on some relay or some light, okay? So now let's say you have only 2 pins. So basically you can only control, okay, the output of those 2 pins. But say, okay, you want a variety of response. Say you want a variety of response to go to your output, but you have only 2 pins. Okay, so what can I do is, okay, I'll take S0, I'll take S1 and S0. So this S1 and S0 will be connected to my controller. Okay, and whenever the controller gives, okay, 0 0, that means 0 on S1 and 0 on S0 also, then this input pin 0 will be reflected at the output. You all got me what I'm saying, guys? Then I0 will be reflected at the output. If 0 1 is taken, if 0 1 is given here, then this input will show here at the output, no matter what the value. Say if the input is 1 here, then it will show you 1 for the second condition. If the input is 0 here, it will show you 0. If the input is something here at input 0, okay, it could be anything. Okay, it doesn't matter. Okay, what it will take the input from input 1. In the same way, for the third condition, 1 and 0. For 1 and 0, it will take the values of the output from input 2. You can see I2, so it will take the values from input 2. So if input 2 is 1 here, so the output also will be 1. If the input 2 is 0 here, so the output also will be 0. Irrespective if this is 0, 1 or 1 or 0 or whatever, it will only take from input 2. Then when you give a signal 1 and 1, it will select input 3 pin, and whatever is the value in input 3, it will give at the output. Till here everyone clear how it is done?
Yes, sir.
So it is basically selecting that pin and pushing it at the output. So this is basically known as a multiplexer. Okay, now let's see what is basically a demultiplexer. Now, as the word suggests, multiplexer and demultiplexer. Demultiplexer is the opposite of a multiplexer. Okay, so let's see the pins. So we have again S0 and S1, S0 and S1, which are the selected input pins, and the outputs are Y0, Y1, Y2 and Y3. So these are your outputs. Here it is named as A, B, C, D. Actually it is Y0, Y1, Y2 and Y3. Okay, so these are basically your outputs. And this is the input which is given. It may be a 1 or it may be a 0. Anyways, so if we select 0 and 0, so we take 0 here and 0 here, then A will be equal to F. Then A will be equal to F. Everyone clear? So whatever is happening, whatever is the value of F here will be reflected in A. Now if we take 0 and 1, if we give 0 here and 1 here, then whatever is reflected at F will be reflected at B. That means say if F is 1 here, it will be 1 here. If F is 0 here, it will be 0 here. Guys, you all are getting me? Hello?
Yes, sir.
You all are understanding this, right? The multiplexer and
sir.
demultiplexer? Yeah.
Yes, sir.
Okay. So here what is happening? More outputs have been given. For the multiplexer, what? Only one output for various. Okay. Here there are many, but only one input. Okay. Now if we select 1 and 0, say I want to give whatever the value of F here in C, then I have to select 1 and 0. When I select 1 and 0, whatever the value of F is there will go in C. And in the same way, if I select 1 and 1, if I give 1 and 1 here, then this Y3 pin is selected. So whatever is in F will go in D. And A and B and C will remain this thing without any changes. Everyone clear? So F will be equal to D when you give it basically 1 and 1 here. F will be equal to A when you give 0 and 0 here. So it is basically like a switch. Whenever you give the appropriate signal, this F is equal to A, or F is equals to B, or F equals to C, or F equals to D. Till here you understood what is a multiplexer and demultiplexer?
Yes, sir.
So this is the only
Yes, sir.
thing what you got to do. Here, this is a diagram of a multiplexer and demultiplexer basically merged together. So you have multiple input signals and original input signals. Okay, so this is how when we basically merge them together. Okay, so now let's go for the simulation. Okay, which one you all want to go for first? Multiplexer or demultiplexer?
Multiplexer.
Okay, and one more thing, right now you all go on your individual PCs also, okay, and go to that virtual labs link. You all already know how to do it, okay? So go and do it yourselves as well. Okay, so now the circuit of a multiplexer has opened up. Now, as I told you, we are not having that single IC. Okay, we are not having that single IC. So we have basically combined the NOT gate, okay, AND gate and OR gate to make a multiplexer. So now let's turn on this. So we'll power the system on. So when we power the system on, okay, it's not lighting green. Okay, but anyways, when we power the system on, all the ICs are basically given power. So now all the ICs are powered. Now this is your S0 and S1. This is your S0 and this is your S1. So coming back to the multiplexer theory, what we have. When 0 and 0 is given, which pin is activated? Which pin is activated at the output?
I0.
I0.
I1.
So I0 is basically
I0.
given to the output. When 0 and 1 is given, I1 is given at the output, right? So now let's see this. This is your main power supply which is turned on. This is your S0 and S1, which are your input signals. Okay, your S0 and S1. And this is your D0, D1, D2 and D3. D0, D1 and D2 and D3, which are basically these I0, I1, I2 and I3, your input signals. So whatever you give here will be reflected at the output, provided which pin is selected. So now let's see. Okay. Now here you can see, okay, there is an output. Here you can see there is an output LED, okay, which has to glow. Okay, so that is coming at your final output. So now say for 0 and 0, this is 0, 0, right? 0, 0. So for 0, 0, which pin should turn on? What pin should be is reflected at the output? Your D0 pin, correct? For S0 and S1, if S0 is 0 and S1 is also 0. So what pin is reflected at the output? Which pin it is? I1, I0, no? So here it is D0. So what it will be? D0. So you can see if I click on D0, the output is turning on. If D0 is 1, it will give a 1 here at output. If D0 is 0, it will give a 0. Now let's see about the other ones. Are they creating any contact? No. See, the output is not glowing. The individual LEDs are glowing to tell you it is on, but the output is not coming on. Output comes on only with D0. You can see this. Everyone clear? Guys?
Yes, sir.
Okay.
Yes, sir.
Again, yeah. Again, we'll check in the this thing. 0, 0 given. So 0, 0. So it y will be equal to I0. So whatever is in the input 0 will be equal to the output. So the same thing is basically happening here. Whatever is the value of D0 here will be reflected at the output. So when this is on, okay, it turns on. When this is off, it basically turns off. And the other pins won't affect. Okay. Now let's take the other. So let's check this. We'll add this situation. Okay, D0, when the output is 0, it is 0. Now let's check the other situation. When it is turned on, and we'll say add, then it is what? It becomes 1. So it is equal to D0, whatever is the value. Now let's go for the next one. Let's take now 0 and 1. 0 and 1. As per the theory, 0 and 1, which is basically I1. So here we have 0, here we have 1. So when D0 is pressed, it doesn't affect the output. But what affects the output? D1. See? So when D1 is turned on, the output turns on. When D1 is turned off, the output turns off. So again, we'll take this case also and add it here. And now we'll add the case when it is turned on. So that case also we'll add here. Till here, everyone clear?
Yes, sir.
Right? Okay. So this is how it
Yes,
is
sir.
done. Now, for the rest of the cases, you all do. And show me the screenshot. Send it on the group. If there are any doubts with regard to this, let me know. You can directly interrupt. Or you get 4 people. Then the last case, both are equal to 1. No matter what is turned on, D0, D1, or D2, it will only react with D2. So this is how it is done. Everyone is clear with this, guys?
Yes, sir.
We'll go on for the next one.
Yes, sir.
You all understood this now, guys? What is the use of it? So with just two input signals, you can manipulate the whole thing. Okay. So it is basically used when you have basically less pins on the microcontroller. So you can use multiplexer and get the job done. All right. Coming back to the next. So we did the multiplexer. Now we will try the demultiplexer. So we'll go for the demultiplexer. Okay, so now in the demultiplexer, they have used an inverter, they've used a NAND gate and another NAND gate. Alright, so first let's turn this on. Okay. Now we'll go to the theory, what we have seen. So now the demultiplexer. So when 0, 0 is selected, when 0 is here and 0 is here, your A will be equal to F. When 0, 1 it is, your B will be equal to F. Okay, so whatever the input is. So now let's see this. Okay, so you have your two inputs here, okay, from the controller, which is basically S0 and S1. Here it is written as select line B and select line C. Okay, so now let's see what we get. So say we selected 0 and 0. So when we select 0 and 0, y0 also should be equal to the input. This is basically our input. This is basically our input. And these are our outputs. Okay. So since here it is 0, okay, then here also it is showing you 0. Now see, if I turn this on, the LED turns on. If I turn this off, the LED turns off. So we'll keep it on only so that we come to know which is basically it's influencing. Then we take for the next case, 0 and 1. For 0 and 1, this LED turns on. Then we'll take for 1 and 0. This LED turns on. And then we'll take for 1 and 1, wherein it turns on this. So with just two input signals, I can control totally 4 devices with this kind type of a demultiplexer circuit. Everyone clear with this? What a demultiplexer is?
Yes, sir.
Yes,
It's
sir.
easy, no, guys? You are understanding?
Yes, sir.
Yes, sir.
Okay, okay. So this is basically your demultiplexer circuit. So even on the circuit board, you basically have to do it in this way only. You have to connect the ICs in this way only on the circuit board as well. Okay, that's it, and we have completed the experiment, guys. Any doubts in this? Please let me know. Guys, any doubts? Hello? You all can hear me, everyone? Guys,
Yes, sir.
yeah, any doubts in this till now? Multiplex and deep.
No, sir.
Okay.
No, sir.
All right. Now you all take 10 minutes and just do it by yourself, all whatever I have taught so far. Okay. Fill up the truth table for this. So first you take your two conditions. So we added this 0 and 0. Then we take when your input is basically 1, add this. Then we take when it is 0 and 1, add this. Then we take when the input is 1, add this. Then we take when it is 1 and 0, add this. Then we take the input is 1. Then we take when it is 1 and 1, and this is 0, add. And we take, see, these are all the conditions which you all have to do, and you all have to show in your file also. These are all the conditions. So you'll get these many conditions. Everyone clear? Guys,
Yes, sir.
now I'll give you all 10 minutes. I'll complete all of this and then interrupt. You all have to complete your files, huh? In Word format. Everything is here. You don't have to do anything much. I believe 4 or 5 experiments are there. You can finish it off
So,
fast. Tell me.
so experiment 1 and experiment 2 will put it in the same file now. Like
Yes, yes, yes.
continue.
Yes, yes, yes. You all can all work with it together. Got it now? Now 5 experiments are there. So you all can split it up between all of you all. Okay? Matter, everything should be the same. So what you have written, the other person also should write the same. Got it now? So you can split yourselves up and do it. There's no problem. Guys, I went through the calculator videos which I sent you all. Any diplomats who have come? Hello.
No, sir.
There are no diplomats this year.
Not in IT.
Okay, okay, okay. All right. You all will have to go. I'll be pushing up new videos also of the calculator. That BCD conversion and all, you can directly do it on your calculator. So I will push up those new videos. For now, you all just go through whatever I have sent you all on the group. Whichever videos are there of the previous calculator, just take a refresher course. We finished our practicals within 30 minutes. It's so easy actually on this. It becomes difficult when you do it on the breadboard, because breadboard you really have to do the connections. You have to put the connections. This becomes very easy.
So after completing the multiplexer one,
Yeah.
so that truth table to remove the screen, sir.
Multiplexer or demultiplexer?
So multiplexer.
Multiplexer. Okay. Tell me.
So what? So I did. I added the cases.
Okay. So first you have to take the first case, 0 and 0. But 0 and 0 also
Yeah.
will have a case where D0 is there and D0 is there, where D0 is equals to 0 and D0 equals to 1. So this is the
Okay.
first case. Okay. Second case also will have two options. Okay, 0, 1 and 0, 1 will have two options when D1 is equals to 0 and when D1 is equals to 1. Then again, third case, 1 and 0, it will also have two options. You can see here, D2 and D2, when D2 equals to 0 and D2 equals to 1. And then the third case, when it is equals to 1 and 1, again it has two more cases when D3 equals to 0 and when D3 equals to 1, which is equals to the output. Clear?
So yes,
Yeah.
sir. So what I was asking is, that you wanted a screenshot, no, sir.
Okay, okay. Yeah, just put it on our group.
So of the truth table of the circuit.
Of the truth table, more than enough.
Okay. And so you have to click anything, screenshot and put on the file, like.
Yeah. Guys, you all can hear me?
Yes, sir.
Yes, sir.
Sorry, it just got
Yes,
cut,
sir.
Ray. Yeah, it just got cut. I
If
will
you get
just
the
share the
voice.
screen. So what I was saying is, say now this is your multiplexer.
Yes, sir.
1 minute, I'll just close unwanted things. Okay, there's an option here, print. Okay, so you can just print this. Okay, and save it as a PDF. Got it
Oh.
now? So this whole page will be visible. See, you can see you have connected it, and these are all your truth tables. Okay, so
Hmm.
it's already there. Just click save, and that's it. So simple.
And so
Yeah.
to put this on the file, no, sir, at the end.
Sorry. Yes,
To
yes,
put.
yes. This is your experiment, no? Conducted experiment. So it goes as your observation.
Okay.
This
Got
will go as your observation, no?
it. Hmm.
So that is what it is. Same thing do for demultiplex also. Once you took all this, just click on print. And you'll get it as a PDF, and that PDF you have to save it in your Word document. Got it. Very easy, very simple. Okay, complete this and send it to me on the group. Is this difficult, guys, or you got this?
Got it, sir.
Okay, I'll just take your attendance. I-1901, 01, absent. 02, Krishna Prabhu was there.
Present, sir. Present, sir.
Sorry?
Present, sir.
Okay. Roll number 3,
Present, sir.
roll number 5, Rohit. Okay, present. Saloni,
Present, sir.
roll number 7, Shane.
Present, sir.
Roll number 8, Shravani.
Present, sir.
Roll number 9, Tarin. She's absent. Tarin Beg, absent.
Yes, sir.
Okay. Roll number 10, Tukaram. Roll number 10, absent. Okay, absent. Okay, present. Okay. Roll number 11, Vishal. Roll number 11, absent. Okay. So totally roll number 11, roll number 9, and roll number 1 are absent. Rest everyone are present. Everyone completed this or are still doing? Everyone completed?
Yes, sir.
Roll number 10 is present. Yeah, I'm marking present.
So he's saying roll number 1.
Roll number 1 is what?
Alias is present.
He's roll number 10, no? Tukaram alias. That is Alia 01. 01 is absent. Hello?
So alias is present. That's what he was saying.
Yeah, alias I marked him present. 01. This Alil Ajimid. I roll.
Alias.
Yes, yes. So roll number 1 is absent. Roll number 9 is absent. And roll number 11 is absent.
So roll number 1 present.
Roll number 1 present. Okay, sorry.
Yeah, he was there.
She was there, but where she is right now?
So he
He, okay. Okay, okay. He's there. He's
came
there.
back.
Okay, got him. Got him. So only roll number 9 and 11 are absent. Roll number 9 and 11 are absent. Everyone completed this or are still doing? Guys, everyone completed this or are still doing? Done? Wow. What about the others?
Wait,
Huh?
sir, still doing. Another 2 more left to be
Okay, okay.
demultiplied.
Complete and then send it to me on WhatsApp. Once everyone has submitted, send it to me. Okay, I got Shravani's. What about the other one? Not only that, multiplexer, demultiplexer, both.
Done, sir. I just didn't send the picture. Wait, sir.
Okay. And guys, I'll have to take a photo for y'all also, so that it comes in the file.
Done, sir.
Yeah, I'm receiving now. Send me a both, multiplexer, demultiplexer, both. Everyone did? Come on, yeah, how much time this is? A simple calculation, not even calculation, just put on and off and you'll get your output. Come on, everyone, finish it off.
Sir. Sir. Sir.
Everyone completed?
Sir.
Wait, I'm one minute. You're saying something, sorry, my volume was low. Yeah, everyone completed? Now tell me, Shane, what you were saying?
What I was saying now is once you remove that print, you told us to remove.
Sorry?
You told us to save it as PDFC by that print method. Yeah. So it's saving only half screen, sir.
Okay, let's see this.
So I'm not getting. Not half screen, like 75%.
Okay, we'll check. I have saved it here, so we'll come to know. Okay, it is not saving in the. Okay, I came to know your point. Okay, wait. Let's see if there's some option where we can. Okay, say we
There
go
is one
to.
option called landscape mode.
Yeah, landscape we have to basically select. So it is
Okay, we
portrait, no?
selected both.
Put it in landscape and see the preview. I think this should solve it, yeah. So in landscape, we're getting the whole thing. 1 into 4 multiplex. Replace. So we'll enter into this and just see. Okay, done. So you're getting in this. Everyone clear? Hello.
Yes, sir.
Huh? So you're getting. Just select the landscape option. That's it. Same thing you can do for that 4:1 multiplier as well. Select the landscape mode. This will come on the second page, but this may come on the second page. I don't know about the way it is taking the whole thing. I think portrait is taking the whole thing, no? No, it is not. Okay, so you have to use landscape only. So what we could do, more options. It's not taking as a GPG. Okay, take it as landscape only. That's the only option there. Okay, everyone completed? All right. Okay, guys, now what we will do is, okay, we will go on through the basic calculator videos, whatever we have. So I have already completed this. I'll want some more time for this practical. Or can I continue? Guys, you'll want some more time for the practical or shall I continue? You can hear me, everyone?
Yes, sir.
You all want me to continue?
Continue,
Oh,
sir.
you all want?
Uh,
Okay,
Continue, sir.
all right. So I will basically go for the this thing, huh? For the calculator videos.
Well, today we're going to talk about the
You can see it, guys, everyone.
X991 ES Plus Natural VPAM series. The Casio
Okay.
FX991 ES Plus has
Yes, sir.
two
All
modes of
right. So you'll
power.
go through all the basics,
First
whatever I have
is
discussed.
your
Okay.
solar panel, which is here, the small one,
In the meantime,
and
you
it
can
has
check
even
this out.
an internal
If
battery.
anything is there, just interrupt me.
So if your internal battery fails, your solar panel will come into play. So basically, this calculator comes in two sections. This is your first section, and this is your second section. Now, in the first section, this part here, this is basically like your normal calculator. And in the second section, which you can see here, this is where the scientific purpose of it comes into play. So you have your normal calculator, what you could do your normal functions like plus, minus, multiplication, division, into, equal to. This will come in your first section, and this will come into your second section. Your second section will be the specialized section for the scientific point of view. So this is your scientific calculator. Now, coming back to the normal things. If you see the first section, it is just like your normal calculator. You have your 0 to 9 buttons. Okay, you have your multiplication, division, plus, minus, okay, decimal point into 10 raised to the power of 9 or any value, you have your answer and you have equal to. The basic function. Now say we have a problem which is 8 into 3 divided by 5 into 3. Now we already know the value. The value is 1.6. So I should get 1.6 when I substitute this value in my calculator. So substituting the value, 8 into 3 divided by 5 into 3. Now this is what we would normally do, because you can input all the terms and this, and it's quite a large display, so you can input how many values you want. So if I press equal to, I get 14.4, but the actual value is what? 1.6. Now why this comes? The reason to this is the calculator substitutes the terms which come first. That means when I input this value, the calculator will think it is 8 into 3, okay, then divided by 5, the whole term, into 3. So it takes first come, first serve. So actually, this is the value, but the calculator will take the value as 8 into 3, which is first come first serve. So it solved for this value, divide by 5, that means this whole term, divide by 5 into 3. So you get it as 8 into 3 divided by 5 into 3, which gives you the answer as 14.4. So now how can we write this whole term in just one expression to save time without this mistake coming into picture? So the most effective way would be to use your brackets. If you see in the second section, you have an open bracket and a closed bracket. So when I take the sum as 8 into 3 divided by 5 into 3, when I'm writing it in my calc, I have to specify open bracket 8 into 3 divided by open bracket 5 into 3 and close bracket. So I have to use my open and close here, and I have to use my open and close here. So I'll open the bracket 8 into 3 close bracket divided by open bracket 5 into 3, and I get my value as 1.6. So this open bracket and close bracket plays a very crucial part in your substitution. So always remember, you can substitute it much effectively like this with the open and close bracket. You could even go for the conventional method, that is 8 into 3, and you get the value 24 divided by, then press AC again, and 5 into 3, and then say 15. So 24 divided by 15. Then again 24 divided by 15, and you get 1.6. But this method is tedious. You could just get it in one step by using this methodology. The other aspect which I want to talk to you about is the replay button. Now see, to come back to the previous, your Casio calculator saves nearly 15 previous values, 15 plus previous values depending upon the size. Now if I want to see my previous value, I can go on this joystick like button which has top, down, left, right. Okay, so I can go on top, and you see your previous substitutions are all here. So say you forgot your substitution, what you did previously, you can get your full substitution, what you have done, along with the answer. So previously I had used open bracket 8 into 3 close bracket divided by 5 into 3, which I get 1.6, which is basically a much easier method. So I can even use the replay button to go on to my previous values. Another thing, if I press my AC button, okay, it comes to the defined screen, but if I press replay, I still have my values. But now if I press the on button, you can see if I press the replay button to check my previous values, they will not be there. So whatever previous values are there, they will all be deleted. So whatever previous substitutions are there, you will not be able to view them once you press the on button. So always press your AC button. So when you press your AC button, you will retain your previous substitution values at least from 15 plus terms. But if you press your on button, all those previous values will be lost. So special care should be taken when you're pressing your on and AC button. So always use your AC button. Say you want to delete those terms or you don't want anybody to check those terms back again, then you can press your on button. All the previous values or substitutions will be deleted. Another thing of this calculator is, now say I type the value 8 into 3 divided by, as I told you, I have to use the brackets. So open bracket 5 into 3 close bracket equals to 1.6. Now say instead of 3 here I wanted 4. It's not needed that you have to press the AC button again and again type the terms. You could just go to the previous value, which is here, and say you want to change this 3 to 4. You can use the replay button. Now replay button, as I told you, the top and down is used to see the previous terms, but the side buttons, that is your left and right, can be used to change your values. So say I want to change this 3 to 4, I can just go here using my replay left and right. I can press delete and change it to 4 or 45 or whatever value. So I can just directly change the value here and press equal to, which makes it very simple. Now 8 into 4 divided by 5 into 3 is a simple value, but say it's a very complex equation which has multiple terms in it. So that's the time this comes in very handy. If you have written the whole term and you just want to change one value because only that one value is wrong, this replay button comes very handy. So this whole thing is known as your replay button, which is just like your joystick, which has left and right and which has up and down. So you can use this replay button and adjust your substitution values. So this replay button holds a very nice way of replacing your values. Now again, we'll press AC. As you see the delete button, we even saw the function of it. So if I have 85 into 6 into 3, I can basically go to any value, press the delete button and change the value to whatever I want and press equal to. So the delete button comes very handy, but I have to use it in coordination with the replay button. Another function which you see in the first section, okay, would be the decimal point. Now if you have 2 into 5 divided by 3, so I can put my decimal point. Now you will see that there is into 10 raised to the power of x. This is for terms say I have a term 2 into 10 raised to the power of minus 3 divided by 5 into 2. Always remember, it is safe always to use your brackets. So if you have any multiplication term or division term, just use your brackets. It's not going to cost you much. Anyways, the calculator is quite advanced. It will give you your answers in the speed of light. So you don't have to worry. So say I have this term. I'll open my bracket. 2 into 10 raised to the power of minus 3. You can see this into 10 raised to the power of x. X will be the unknown variable which we have to enter. So into 10 is already given. So I can just directly press this. I'll input that value minus 3. Now I can use this minus 3, or I could use this minus 3 which is here in the second section. This is basically also correct, and it gives you a better understanding. You see the size of this minus and this minus, okay, the size of this minus is smaller, the size of this minus is bigger. This minus basically helps to tell you that the value here is in the superscript. So whenever you see this minus, it will directly give you a hint that it is a superscript value. But otherwise, you could even use this minus. It's not a big issue. Again, close bracket divided by open bracket 5 into 2 close bracket, and this is your value. So you could use this 10 raised to the power of minus 3 or minus 4 or minus 5 or 10 raised to the power of 6 for whatever calculations you require. So now say it is 2 into 10 raised to the power of 5 into 3 into 10 raised to the power of minus 7. So again, how to input it? I have bracket 2 into, I have bracket 2 into 10. I don't require the into sign because it already includes it. 5 open bracket into 3 into 10 raised to the power of, I can just directly use this, minus 7 close bracket, and I get a value as 0.06. So in this way, I can find out my values. I can even go back to the previous using the replay buttons as I told you. So of my first equation, it is 2 into 10 raised to the power of minus 4. So you see, I don't lose my values, but if I press the on button, my values will be lost. Another important function of this is, now say I got this answer, I press equal to, I got the answer as 0.06. Now say if I want to substitute this value of 0.06, what I achieved last, into 102. So I want 0.06 into 102. So it's not required that I have to input 0.06 into 102. I can just use the last answer. This answer button is basically the last answer. If I press answer and I press equal to, the last answer which it had substituted comes, that is 0.06. So what I could do is I could just press answer, which would include this last substituted value, into 102. So I can get the value directly as 6.12. Let's recheck that in the manual way. 0.06 into 102. As you see, it is 6.12, which is the same answer what I got here. So whenever it takes the last substituted value. Now you see, if you press AC and you press answer and you press equal to, it will give you 6.12. It will not give you this value because it takes the last substituted value, which is 6.12. So this answer will always be the answer that you got in your last substitution. Okay, so this is the basic functions of your calculator, that is your section 1. Now you have a section 2. Now in your section 2 you have x raised to the power of 2, x raised to the power of 3 if you see your gold terms. Then you have x raised to the power of whichever value. Then you have log, you have in, you have 10 raised to the power of whichever value. Now, if you can notice, there is x raised to the power of 2 here, and there is x raised to the power of 3, which is in gold. So there are two buttons which is basically highlighted in gold. If you could see, it's highlighted in gold and it is highlighted in red. So you have these two things. So gold is represented as shift and red is represented as alpha. So you have shift and you have alpha. It is just like your normal keyboard. Say if you want to type the letter A in capital, you would use shift and A. Or I could even use caps lock, but I can use shift. So I have to press shift and A. So that will give you in capital. And if I want to just use in normal alphabets, small letter alphabets, I can just directly type A. So this shift and alpha basically act like those keys which change the value of that button. So now now we have x square and we have here x cube, if you could see. So x basically represents any value. Say if I want 5 square, I want the value of 5 square. So what I have to do is I have to type 5 and then I have to press square, which is equals to 25. So this is how I get the value. So this x will represent the variable value I want to find out. So now say if I want to find out the value of 5 raised to the power of 2 or 5 square. So I have to just press 5 into this value, which will give me 25. Now say if I want to find out the value of 5 cube, it will be 5 shift. Now when you press the shift key, you notice your S comes. If you press your alpha, your A comes. So now I'll press the shift, which will basically target all the gold terms in my calculator. So now you see what? X into 3. So I press this. So it will be what? 5 cube or 5 raised to the power of 3, which is equals to 125. So this is how I can find out between square and cube. So if I can find out any value raised to the power of 2, and I could even find out any value raised to the power of 3 in this fashion. So this is for my square and this is for my cube. But now you will say, obviously values are not restricted only to 5 square or 5 cube. Okay, they can even be values raised to whatever value, that is x. So for that we have another button here. So now say if the term is 105 raised to the power of 18. So if it is 105 raised to the power of 18, I press 105 first. So 105 raised to the power of 18. So what will be the value of this? So 105 raised to the power of 18. So I press 105 and then I press this button right here. Okay. Now which says that 105 raised to the power of 18 and close the bracket. So this is 105. This arrow button here basically indicates raised to the power of 18, or it indicates the superscript. So 105 raised to the power of 18 will give me 2.4, since it is 6, so 2.41 into 10 raised to the power of 36. So this is the value I have achieved. So it means 2.41 into 10 raised to the power of 36. Never forget to include this 10 raised to the power of 36. Okay, you will get your value into this term. So always remember to take this term into consideration as well. So always look out for your last term. If it comes 10 raised to the power of 36, then obviously you have to even include this, because this holds the major difference in your answer. So always remember to write it down. Now, pressing AC again. The other thing what we have to see is the log. Now, when you come in the studies or engineering studies point of view, we don't need a log table because the scientific calculator already provides us that option. Say you want to find out the value of log 18. So I just have to press so now say you want to find out the value of log 18. So if you want to find out the value of log 18, you just have to press the log value, press 18 and close the bracket. So you get the value as 1.255, which is equals to 1.256. So this is basically the value of your log 18. Now if you notice how you press it, you press log, the open bracket directly comes up and you press 18. Now I'm not closing the bracket, I'm pressing equal to. I'll get the same value. There's no problem with this. But if now say the value was log 18 plus log 6. So I want to basically differentiate between these two terms. So for that reason, the bracket comes into play. So now if I have this value, I'll just go to my replay. I close the value. I close the bracket plus log 6 and close bracket. So it's always good to close your bracket. So if you have a bigger term, it can be substituted properly. So if this bracket wasn't there, okay, then you would get a different value, which is basically wrong. So as I told you, brackets play a key role. So always don't mind to put that extra bracket into account. It may just waste 2 seconds of your time, but it will give you a correct answer and you will never go wrong. So always include your brackets. So this is how you can find out your log values as well. Now, say you have root 2. You want to find out the value of root 2. So what I have to do, I have to press this root sign here and I have to input the value. As you see, open bracket. So always close your bracket. So how much you get? 1.414. Now, this is for root 2. Now say it is root 5 and again root 5. Whatever value it is, you can push in and close bracket. So this is how you can get your root values. Now, this is for square root. Now say you want a cube root value. Then what you can do is press shift and aim for the gold key, which is here. I hope you can see it. Okay, so the gold key will include this cube root. So I press the cube root sign. So say cube root of 2 and close bracket. I can get my cube root value as well. So if I want cube root of 2, the value is 1.26. So this is another function. Now this is for square root and this is for cube root. But now say I want of any value here. So this could be any x value and any x value here as well. Because obviously in engineering we are not just restricted to square root and we are not restricted to cube root. We can even have 4 root or we can have 5 root. So say it is 5 root and the value is 25. Now how you will input this? Now if you check here, there is another function near x raised to the power of anything. You could see here you have a root sign which basically gives you any value, if you can see, which is basically highlighted in gold. So I press this shift button, I press this here, you can see it is x root and you have to input your value. So any root will do. So now say you have an example here, 5 root of 25. So I have to first input 5, shift, put that button. So this x will be the 5 value, which is my 5 root, and now 25 and close bracket. So I get how much? I get 1.904. So this is how I can get 5 root of 25. So what I have to do is just press this button. Now I will just cross check whether whatever I have done is correct. So what I could do is I could take the cube root value and put it in this same way. So if I have cube root of 2, I should get 1.26. So I'll use the same button here. So what I have, cube root of 2. So I'm pressing 3, shift this button here for any value. So now the 3 basically represents my cube root. Root of 2, close bracket. I get is 1.26. Basically decimal point shifted. So 1.26, which is the same value as I got when I typed directly the cube root of 2. So I'm getting the same value. So this is also okay. But if you have cube root, I feel this is much more easier. Where you can get your answer easily. But both the ways is possible. But this is like a universal way where you can input any value. So this is how to substitute the value of cube roots, square roots and any root values. Then you have your sine, cos and tan. So say if I have sine 50, I have to press sine 50 close bracket. So I'll get the value of sine. I can even do sine into cos 60. So if I have sine, I can just go to replay into cos 50. Okay, and as usual I did not use the bracket sign, so kindly use the bracket sign, although it doesn't make the difference here, but still. So sine 50 into cos 50 will give you 0.49. So this is how we got this value, 0.4924. So it becomes very simple. So even if I have division, sine 50 divided by cos 50, I could get it done very easily. So this is how you can even use your trigonometry values. You have sine, cos and tan. So I could use my trigonometric functions as well. Now there's one more button here known as ST. So say if I have a value 5 into 6, how much I get? 0.83. If I press the ST value, I get 5 by 6. This ST value basically converts your fraction to decimal and decimal to fraction. So now if I say the value is 0.83 for 5 divided by 6, if I want to know my fraction value, it is obviously 5 divided by 6. So when you see this sign here, it basically means 5 divided by 6. So I can get into the fractional point of view easily by just pressing this S to D conversion or D to S conversion. So say if it's a complex term, 5 into 3 divided by 52 into 6, a complex value, it will be 0.04. But if I want to know the fractional term, I'll just press this button and I get 5 divided by 104, which makes it very easy if I want to know the fractional value. So it will be 5 divided by 104, which is the same as 0.048. So it will give you the same answer, 5 divided by 104. Even if you see 5 divided by 104, you'll get the same answer, which matches with this answer. See, again, I'm using my replay button to go to the previous terms. This is what I got, 0.048. Again, 5 divided by 104, 0.048. Again, ST. So 5 divided by 104. So this button also holds key importance. We covered the basic functionality of this calculator. Now, there are other functionalities as well, which will be told in the next episode, which will be taken up into 2 separate episodes, that is advanced mode 1 and advanced mode 2. So thanks for watching and stay tuned to the next video of advanced mode 1 of FX991 ES Plus. So in the trigonometric aspect, I basically covered sine, cos and tan. But sine in... Well, my name is Professor Viren Pereira and today I'm going to talk to you about the advanced modes 1 of FX991 ES Plus. Now, before we go to advanced modes, there was a certain topic that I did not cover in basic functions, which is the trigonometric aspect. So in the trigonometric aspect, I basically covered sine, cos and tan. But sine inverse, cos inverse and tan inverse were remaining. So if you see just above sine, cos and tan, there is something known as sine inverse, cos inverse and tan inverse. So if I want to find out, say suppose the value of sine inverse of 0.3, then I have to just press shift sine inverse. As it is in the goal term, my goal terms will get activated by the shift button. So I have to press shift, I get the S out, which you can see here. So once the S comes, I press the sine button to activate sine inverse. So sine inverse comes on my display. So I have to press sine inverse, and since I want to know sine inverse of 0.3, I say 0.3, close the bracket. Always close your brackets to be on a safer side and press equal to. So I get the value as 17.457. So this is basically my value. Now, 476. Now cos inverse, again shift and press cos, so that will give me cos inverse of 0.6 and close bracket. So I get the value as 53.13. Now tan inverse. So again I press shift, tan inverse of 0.5. So 0.5 close bracket, and I press equal to, so I get a value of 26.57 since it is 5. So this is basically the values that I have got. So I can even get sine inverse, cos inverse and tan inverse as well. There is even another function which I want you to know. If you see on top of log, there is 10 raised to the power of any value. So if I press shift as it is in gold for 10 raised to the power of any value, I get 10 raised to the power of the value which I want. So say I say the value is 10 raised to the power of 3 and I close the bracket. So how much will I get? 1000. So this basically represents 1000. So if I have a term like 8 into 10 raised to the power of 9 plus 3. So if I want to add this entire term, I can add it in a calculator with just one step like this. I open bracket 8 into 10 inverse of 9, close the bracket of this 9 and then again close this major bracket plus 3. So I get the value as 800000003. So this is how I can find out the value of this problem. So there is even another aspect which I want to share some light on, which is with the alpha button. Now if you see, if I press shift, the S button gets displayed. If I press alpha, the A button gets displayed. So alpha will target all the terms dealing with red and shift will target all the terms dealing with gold. So this is how it works. Now coming back to the advanced modes 1, which is basically dealing with episode 3. Now in this we will basically study all the various modes that this calculator can operate on. So which special modes it can operate. So if you see, there is a mode button here written mode, and there is another button on top of mode known as setup. So first we will see the options in mode. So if I press this button, I get my options. So I get comp, I get complex, statistical, Bayesian, equation, matrix, table and vector. Now if I press the replay button downwards, you see I don't get any more options. So if I press it left or right, I have no options. So I have only the options from 1 to 8 and no more. So from this 1 to 8 options, the major options that any engineer should know is basically your Bayesian calculation, your equation, your matrix. So these are basically your 3 major functions that any engineer should know. Now, what is basically your Bayesian calculation? So Bayesian calculations basically deal with converting your binary to decimal, decimal to binary, binary to hexa, hexa to octa and so on. If you can see, there is something written here as decimal, hexa, binary and octa. So this will basically deal with your binary calculations. Now your second most important function is your equation mode. Now in this equation mode, if I press 5, I can solve for simultaneous equations. But if you see the first and second option, I can solve basically maximum for only 2 simultaneous equations or 3 simultaneous equations. But anything more than 3 I cannot do. So I can only use this to solve 2 and 3 simultaneous equations. Now the third option can make me solve for equations dealing with square or equations dealing with cube. So I can solve square and cube equations as well. But my simultaneous equations are basically limited to only 3. Now coming back to mode, I have another mode which is the third most important in every engineering college, which is your matrix mode. Now your matrix mode can be used to find your determinant, it can be used to find transpose, it can be used to multiply, divide, add and subtract matrices. So this matrix mode is also one of the most crucial mode which is used in every engineering study point of view. So the matrix mode basically helps you to do all these functionalities. You're having options of 3 matrices wherein you can multiply, divide, add, subtract, find the determinant, find the transpose and so on. So this matrix option plays a very vital role in the scientific calculator. Now, apart from the mode, if you see in gold it is written setup. Now to activate setup, obviously since it's in gold, I have to press my shift key and then press this mode button again. So I enter my setup. Now in this setup, I have mathematical, linear, degree, radians, grades, fix, scientific, normal, and now here if I press my replay button, I get AB divided by C, I get D divided by C, which are fractional values such that, for example, if I have a value 3 into 5 divided by 6, so I can push that value using this form. But since I'm using brackets, I don't require to use this form, and since brackets are more easy and makes it more user friendly, we can basically avoid these 2 modes which make it more complex in nature. Then I have my other modes like statistical, display and contrast. So I have around 1 to 6 here, and if I press my top button I have 1 to 8 here. So this setup also basically proves a very crucial role. Now we saw the mode button and the setup button and how many functions they basically have. Now if you just check this calculator and if I press my AC or I press my on, I only get one thing displayed, that is my degree mode. But this basically doesn't come at its default state. When you open your calculator from the box or when you buy it new, it basically comes in a different setup point of view. Now I have modified this setup to basically tweak it to my settings. So the setup function is basically like a tweak so as to enhance the performance capabilities of your calculator to suit your expectations or to suit your answer compatibility. So this is basically the plus point about the Casio calculator. Now let's go to each of these modes individually and find out. But before we go to that, let's get the point that I made before, that when your calculator is bought new, does it come in this form? No, it doesn't come. So let's see. Let's put this calculator back to its default state. So if you want to put the calculator to its default state, what you can use is, you see this 9, on top of 9 is something written as clear and it is in gold. So let's press shift to activate that clear function and 9. Now you can see I got clear. wherein I have options such as setup, memory and all. Now setup means it will only clear the setup function whatever you have selected. That means if I have modified my setup function so as to tweak the calculator as per my liking, it will delete all those setup functions and get the calculator to its previous state. That is the state in which it came when you initially bought your calculator. So it basically restores the calculator to its original default setting at the time when you bought it. So it will be the same setting as per that time. Now, what do you mean to say by memory? Now, your second is memory. Now, as I told you, your Casio calculator can even save some particular values. So, in case you saved some particular values, so when you press 2, so whatever values you have saved in those specific blocks of memory will be deleted. So say if I saved alpha A, so say if I saved the value of 27 in A and now it is saved in my Kelsey, if I press clear and if I press 2, that alpha A will get deleted. So whatever value I saved in alpha A will go and it will go to 0. So all your values will go to the default setting. So the default setting is 0. So no matter where you saved it in your calculator, it will go to 0. So this will only delete the memory part without touching the setup. And when you say 3, that is all, it includes restoring your calculator to your initial default setup and to your initial default memory setup. So that means whatever setup you have done or whatever tweaks you have given to your Kelsey will be deleted and it will return it back to your original state when it first came to you when you initially brought it. And your second memory basically deletes all your memory, whatever values you have saved in it will go to 0 by default. So when you press all, both the setup and the memory will get deleted. If you press only setup, that is your first option, that is 1, only your setup will go. If you press 2, only your memory will go, but your setup will remain intact. And if you press 3, all will go. So this is basically how it works. And one more thing, if you press setup, only your setup functions will go. Your memory will still remain intact. So this is how your clear function works. So now let's press clear all. So I want to press all, so I use 3 because all represents 3. Now you see reset all. You get two options. If you want to reset everything, press yes. If you don't want to reset and you want to come out from this, press AC. So I want to reset all, so I press equal to, and then reset all, press AC key. So now it is reset and now my calculator is in its default state and now the settings are all default and it resembles the state or it resembles the setup when you initially bought this calculator. So now you see you have a degree and you have a mathematical. So degree mode should always be there, which I wanted, but what I have got additional is the mathematical mode. Now I don't want the mathematical mode because it doesn't suit my preference. So if I want to take out the mathematical mode, since I'm basically going to use brackets and make it more friendlier for my liking. So if I want to remove it, I press shift, I go to setup, and you see here the first option is mathematical, the second option is linear mode. So I will prefer a linear mode. So I press 2 for linear and you see the mathematical mode disappears. Now I would basically prefer not going with the mathematical mode because I am a person who would like to use the brackets more rather than using your setup function which you had seen earlier, that is A into B divided by C or D divided by C. So instead of using that, I would prefer basically using the brackets because it makes it much simpler, and because it makes it much simpler and more user friendly point of view. So anyways, it depends upon user to user. Some users still prefer the mathematical mode, but it's my strong opinion that I that brackets prove its usefulness to a global audience, and it basically helps to cut down unwanted mistakes as well. So I would still prefer that you go for the bracket mode, but anyways, that is up to you. Now coming back to the setup. Now there is one more thing which I wanted to tell you. Now you see, for your sine inverse of 0.3, you got the value as 17.4576. Now most of us people, okay, or at least at the time of examination, would not basically write such a big value. Now if I type in sine inverse of 0.3, that means shift sine inverse of 0.3, close bracket, I get this value 17.45760312. Now at the time of examination, say I am asked to find the value of sine inverse of 0.3. It's highly unlikely that I will write this whole value. I will basically reduce this value to 17.46. So I'll keep it basically up till 2 decimal places, and this is the basically the value which I require, because this makes the value too big. And as far as all engineering studies go, the minimum decimal places you can keep is up to 2 decimal places. You can even go for more, but it basically makes no sense. So we are basically only interested in 2 decimal places, which is globally used. Now, if you want to set or tweak your calculator settings, what you have to do is press on again, press shift, setup, and go to this option known as fix. So fix is representing 6. So I press 6. Now you see the fix is basically telling me from 0 to 9. So now if I want 2 decimal places, that means I have to press 2. If I want 1 decimal place, I have to press 1. And if I don't want any decimal place, I have to press 0. So I want basically 2 decimal places. So I press 2. So now you see, when you press your AC, you don't get it as 0, but you get it as 0.00. Now let's try putting this sine inverse of 0.3 and see what we get. So I press shift, sine inverse 0.3, close bracket, and I get my answer as 17.46. So it basically already shifted all my decimal points for me. So I did not have to calculate all this. I directly got my answer as 17.46, which makes it very convenient at the time of examination. Many a times I have seen people having this fix option, but they don't know what it is. So this is the major function of fix, and it has vast uses. So if you're using this, it's better that you know why you're using it. So kindly use the fixed value and use it wisely. Simply just don't add the fixed value when you don't know it. So only if you know it, and since you're seeing the video, use the fix option wisely. So you can basically use this fix option to get your answers directly in this form, thereby saving a lot of time in the examination. So this is how you can use the fix function. Now, many a times I have seen people putting the fix option, but they don't know what it is. It's always wise whenever you buy a product to open your manual and check it one time, because your manual basically tells you each and every functionality of your calculator. But still, if you don't know an option, please don't add it. Now, I will tell you the technique how to come out of fix. Now, say you want to come out of fix. You again go to shift and setup. Now you see there is something known as normal, that is 8. So I click on 8 and I press 1. So see, now your calculator is returned back to normal. See, if you press setup again and you press fix, by pressing 0, you will not return to it. You will still get it as 0.0. I mean 0 point. So basically, if you want to come out of fix, you have to press shift, go to setup and click on normal. So normal is representing 8. So I'm pressing 8 and press 1 and I come out of fix. This is the only way you can come out of fix. Now, another function which is of greater importance is if you press your arrow key, if you go on mode, if you go on setup, you can see 1 to 8. I've got my mathematical, linear, degrees, radians, grades, fixed, scientific, and normal. Normal, I told you, if you want to come out from fixed. Then if you press your arrow key, which is down, okay, you get something known as display and you get something known as contrast. Now, what is this display? Now, if you see, if I press 5, it gives me two options. So, your decimal point can be represented by a dot or a comma. That means if I have 17.46, I can get this represented as a dot, which is 17.46, or I can represent it by a comma, that is 17.46. So let's see this. So now it is assumed a dot by default. So let's select comma. So I press 2. Now I will type 17.46, and if I press equal to, you see I get a comma. So it will become 17.46. But I would still prefer the dot format. So again I will change it back to the display and select dot mode. So now if you see, if I type 17.46, I get it in point. Another function is your contrast. So if you press 6, I can adjust the darkness. So I can make this more darker, as you can see, and I can make it more lighter. So I can select the contrast option from the calculator and make the screen or the LCD more darker or lighter in nature. Another function which you can use is your scientific constants. Now, you all might have known that in physics and chemistry or other subjects dealing with applied sciences have a lot of constants, and it basically becomes very difficult to remember all these constants. But your scientific calculator makes this easy. Now, if you see, you have your, I hope you can see this, you have your scientific constants written here. So I have my gravity constant, okay. So I have my gravity of Earth, I have my gravitational constant of the universe, that is my G. So I can find out all these constants. I have epsilons naught, I can find out the values of all this. So it becomes very easy for you to get the values of your constants. So say I want to find out the gravity of Earth. So the gravity of Earth is given as G. Now G is representing which value? 35. So what I have to do? So the methodology is already given here, how you have to get it. So say I want my gravity constant. Now gravity constant is representing which number? As you can see here, it is 35. So what I have to do is, you can see in this gold, it is written constant, and here it is written conversion, CONV, which represents conversion. Now I am only talking about the constants. So if I want my constant value, I have to press shift. Okay, so the shift button has come here and I press constant. Now it is asking me which constant you basically want to know from 0 to 40. Since from here I have 0 to 40. So say I want my gravity constant, that is representing number 35. I press number 35 here. So 3, 5. So it got my G. So if I press equal to, this is my gravity constant. I can even use this gravity constant directly. So say if I want to say 5 into G divided by 6. So I can directly get the answer straight away. So this makes it very easy, and your brackets basically hold the most best advantage that you can have. So you can manipulate the term right away and you can tweak it as per your liking. So you can get that full expression on your display screen and get the answer right away instead of finding it out individually. So this is one way how you can get your constant values. Now say I want to find out the gravitational constant or the universal gravitational constant. So universal gravitational constant is basically expressed as G, which you can see. Now it is representing number 39. So now if I want to find out that value, how can I do it? Again, simple technique, press shift, constant. What is the number? 39. So if the number is 39, I press 39. Directly my G comes up. If I press equal to, this is my universal gravitational constant. So you can see all these constants are given to you. So you can use these constants directly, and it is totally legal as all the engineering colleges have accepted this calculator. So it's not like you're cheating or crossing any laws that define your code of conduct at the time of examination. So this calculator gives you all that constants, and it's totally legal to use all these constants. Only the thing is, people don't know that these constants are already there and they try to study them by heart. As I told you, engineering is basically applying. The information is all out there, only you have to apply the information. So kindly go through your calculator before you start using it. Another important function is your unit conversions. That means you can convert from inches to centimeter, from centimeter to inches, from feet to meter, from meter to feet, from yard to meters, from meters to yard, and so on. So you can do all these conversions here, even your Fahrenheit to degree Celsius, your degree Celsius to degree Fahrenheit, and all this. So this also becomes a very crucial factor for conversions. So if you want to use it, so say I have degree Fahrenheit and degree Celsius. Say I have 35 degree Fahrenheit and I want to convert it to degree Celsius. So I press 35 and now I have to get it to degree Fahrenheit. So I press shift and I press 8 for conversion. So when I press shift and I press 8, I have to now add my number. So what it is, 35 degree Fahrenheit, which I want to convert to degrees Celsius. So Fahrenheit to Celsius is 37. So I press 37 here. So you see, I get 35 degree Fahrenheit. Now I want to know my Celsius value. So I press equal to, so this is my Celsius value, that is 1.666 degree Celsius. Now obviously if I had it in fix, which I press 6 and I press 2 decimal places, I can get this value right away. So this fix also, as I told you, plays a very important role. But anyways, coming out of it and using only your normal mode, this is how it is. So I can basically convert from degree Celsius to degree Fahrenheit, from yards to meters, from meters to yard, from centimeters to inches instantly with this conversion. The other most important factor about the conversion is your HP to kilowatt, which is basically used in electrical and electronic engineering, which is basically used in the basic subjects of E-Tech, electrical and electronics, to convert your HP to kilowatts or your kilowatts to HP, which is represented as 29. So say you have a motor of 5 HP. So I can press 5 and say I want to convert this HP to kilowatt. So I press shift conversion. HP to kilowatt is 29. So I put 29 here. So now I have 5 HP. So my 5 HP is basically equal.
Hello guys.
Yes, sir.
Wow, y'all are there, huh? I love the sincerity of y'all. Really nice.
Thank you, sir.
Okay. Anyways, I think it's already become time, and I don't know if y'all got bored by now. Okay, so I think I will suspend the class. Anyways, it's nearly going to become 4. Just some 3 more minutes. Okay, you all can, anyways, I have already provided you all the link on WhatsApp. Whenever you all get time, you'll just go through it. I'll be uploading more videos on the calculator regarding the binary and decimal conversion also. So in the exam, you don't have to think much. You can just directly do it on your calculator and see if your answer is right. So you can get full marks. Everyone clear? Okay.
Yes, sir.
All right. So you'll just be in touch with my channel also.
Yes, sir.
Check it out. See whatever is there. If there are any improvements and all, you can always message me on WhatsApp. Okay, and tell me what should I do or what should I include. Okay, so it will be really helpful for you all also. All right. Okay, guys. Take care.
Thank
Bye
you,
bye.
sir.
Bye. Bye bye.
Bye, sir.